Hey everybody, this is Larry. This is day, okay, it's quick, but 18 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. And today we have a hard. We have 1931 paint a grid with 3 different colors. Hit all the buttons. Yeah. I just ran like 5-6 miles. I just came, oh not just, but like it's been a week since I came back, and I'm trying to ramp up on the mileage. Man, I am not in shape. You lose it very fast, but you also regain it very fast once you very quickly if you have done it before once. So hopefully, this is the same with Leetcode, right? All right, let's take a look. First, I see a mod just peeking, so let's get the mod in there. All right. Okay, so what is it? So you have a grid. Consider all each cell is right. You painted red, green, and blue. All cells must be painted. Number of ways with 2 no adjacent cells. Okay. The key thing to note is that M is 5, so that's interesting. But yeah, I mean, I think this is one of those things where if you have enough practice, it does become a little bit straightforward. I don't mean to say this is easy, but they're really just, you look at the constraints and then you think, well, how to exploit the constraints, right? And for this, maybe I'll convert this to R and C, right? I always like R and C better because it just defines a little bit more. Also, I have crazy allergies because, I don't know, I was hanging out in the Prospect Park here in New York City to watch other people do the Brooklyn Half. But as a result, I think everything I own has pollen everywhere, and I'm just like, now I'm suffering. Because yesterday I was okay, but today I am suffering a lot. Allergies. Maybe I need to... okay, I'll do it afterwards. I was going to say... actually, I have quarantine here. But in any case, yeah. My apologies. But yeah, okay, so, well... so what does this mean, right? So I think it's just trying to figure out states, and states that are just fast enough. It doesn't have to be that fast overall. It doesn't have to grow fast or grow slow or whatever. It just has to be just fast enough for the constraints. And that is the basis for a lot of these dynamic programming things, right? And then here, well... I think the way that I would visualize this is that, actually, let me bring up the drawing thing. It's, instead of me trying to do more ASCII art. Right, for this one, I think one of the things that you may consider doing is just try to figure out, okay, if I'm trying to paint a cell, what do I need? Or what does it depend on, right? So here, let's say we have... a grid, and of course, apparently R is much fewer than C, right? So you have a grid, and then now you're trying to look at this cell, for example, right? Then what does it need? Well, this cell, and let's just say for the purpose of loss of without loss of generality, we're going this way and this way, right? Doesn't I mean. You could flip it if you like, if you prefer the other ways, right? So now we're going here. That means that all of these are filled out, right? And then the others are remaining to be filled. And then now the thing is that, okay, well here, how do we choose a color that is valid, right? Well, we choose a color that's valid by not impeding on the previous one. So we need this. Obviously, we also need this because then we need these two things to not equal to this cell's color, right? And then, of course, if we're going to finish, then we go X and X. But the reason why we don't have to consider these is that, well, we will consider them in the future. Because when we fill out this, one is they don't have color yet, but when they have color, then, there's a symmetry-ish thing of, for example, when we go here, then now we would consider it backwards that way, right? So we don't have to do it forward. And then also when we're here, we'll consider it backwards, right? So this is enough. And then now we consider, well, okay, that's fine, right? Then what do we need? Well, okay, so definitely we need the previous cells, previous columns item, and then also just the previous cell, right? And that's basically it. Because then now you think, okay, let's say we fill this color and then now we do another one, right? Let's say we now look at this one. Well, this one, we also need this one. So then now, that means that to fill out this row, or this column, sorry, for this column, we need all of each row, right? Each different thing of each row. And And yeah, right. Maybe you could even say, I mean, there are different. No, I mean, and you also probably need the rest of this stuff too, right? And that's basically the idea. But then the question is, well, okay, you need it, but is it fast enough? And that's where it comes in. Where okay, well, there's only 5 rows. That means that there's only at most 5 cells. Actually, this is 5 cells, right? That means that, and each of these has 3 colors, right? And that means that if we kind of look at it here, then the worst case maybe, use another color. Let's say this is the worst case, because then now, actually maybe not. I mean, you can certainly require the last row, but actually you don't even need all of the last row, because as soon as you move from this cell to this cell, then you don't even need this anymore. We don't even consider it anymore, right? So that means that you only need the last 5 things, right? So you need this, 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 this. And each of these has 3 colors, as we said. So that means that we need 3 to the 5th, right? So there's only 3 to the 5th number of previous state, right? 3 to the 5th times R times C for each cell. Each cell has 5 previous things, up to 5 previous things that we care. Up to 5 previous things that we care about, and that's it, right? And R times C is 5 times 1,000. So I'm just looking, right? So that means that is 3 to the 5th times 5 times 1,000, which should be good enough, I think. Maybe, I don't know. Let's bring out the calculator real quick. What's 3 to the 5th? If I got done that, 243 times 5 is going to be a little bit more than 1,000. Times 1,000 is 1,000,000, and we are good, right? And here, for each cell, we can just, in that case then, we can brute force all 3 colors. And that's it. And that, yeah. And so, yeah, that's pretty much it, really. And then now we just have to implement, right? Hopefully that was a good, visualization, right? So then now we have, let's just call them count, and then mask, and then XY, right? It's not a mask, sorry. It's not it is a mask, but it is, maybe it's not. Basically, you want a base 3 mask, because the idea being a mask in this case, and actually maybe you don't even need to. Maybe I could actually do, okay, fine. No. Let's just convert this to an array, right? Let's just say we have an array. No, let's just do math. I mean, okay. I think I got this. Let's do it this way, and then we'll talk about it, right? And for today, I know that sometimes for easier dynamic programming problems, I'll go over the dynamic programming mechanics. Today, just for this problem, we'll skip that part a little bit. I'll assume that you have the basic dynamic programming problem down. If not, then there are a lot of problems on Leetcode, and I have a lot of videos, so you probably could check some of those, and probably I will explain them, because I did them more in the past, but today I can't keep my eyes open because of allergies. But yeah, okay, so then now, if X is equal to R, then we're done, right? That means that we pass all the rows, and then we're done, so then we return 1. I think that's good, right? And then we have total for the count, return total, right? What we want to do with this mask, and I'll use a helper function, but or get, right? And what I want to do is just convert this into the, like we said, the last 5 things, or well, up to 5 is the last all things, right? So here we have a get mask, right? Get the last all colors, right? And then we just have an array, maybe. Yeah. And then this is just while mask is greater than, well, actually while length of, I guess just we could do a for loop then, for do in range of R, right? Then now we want to say we append mask mod 3, right? And then mask we divided by 3, right? Because it's one of the 3 colors, 0, 1, 2. I mean, this is right, but I think we generate extra colors. That's why. Yeah, maybe that's fine. I don't know. Maybe that's fine. Okay, yeah. Maybe we'll check it here. And what we want to do now is just, it gives me an array of all elements with mask 5, and we just then base it, we just use a base 3 number to represent this mask, and then so that we can use the cache. But now we get the array back of the colors, right? So yeah. And then here we want to check, the previous column. So the previous column, it's going to be yeah. So we have x minus. Okay, let's define this real quick. X goes from 0 to r minus 1 if you want to be inclusive, right? So that means that to fill this, we want to check x minus 1, y minus y, right? So the same column, but the previous row. So that's going to be, and just by convention, you can say this is the first element, right? Yeah. So the last element that we added. So it will be in the beginning. Yeah, maybe. Right? So this is the color from the so color above, maybe, right? So it's the row above, and then it's the column above, and then color of and also just be consistent. To the left, it's going to be r of r minus 1, so it's going to be the last element, right? But there's going to be no left if so we do have to check some stuff, right? Yeah, because basically if x minus 1 is equal to 0, and that means that, you know, yeah, that then we can do this. Else color above is equal to -1, so then it never matches. And then we do something similar for going to the left, right? So if there's a left, otherwise color left is equal to -1. Yeah, just like a fry. But yeah, it's very awkward, but I think this is fine, right? And here, maybe we actually want to how do we want to write it? Yeah, I mean, and then now we just permutate the brute force the 3 different colors, right? So then now C has to be not equal to color above, and C is not equal to the color left. Then we use C, right? How do you use C? Well, total we add count, mask we have to update mask. Let's just say update, right? And then it's going to be technically you want the next row, right? So x plus 1 y, right? So this is actually wrong. I think we want the base case to be y is equal to C. But then also if x is equal to r, then we go to the next thing, right? So count the same mask, but then we the first row, y plus 1, right? So use the next column. So basically, if you wrap around, you just go to the next one. That's what this does, and this makes it so that I don't have to write. I mean, I guess you could write an if statement here. It's fine, right? And that is in theory good, right? Except for that we have to update the mask. How do we want to update the mask? There's a lot of ways you can do it. You could even you could convert it back, and then I'm gonna do it a very silly way. It may time out, and then we have to do it like the actual smart way. But yeah. So then here you can maybe say new array is equal to make a copy of the array, and actually we just want to use. We want to skip the last copy, so we no wait, yeah, well, is this is C plus this, right? So then now it basically removes the last copy and put it in the front. Almost like if you have a deck, you remove the last entry and then you add it to the front. So then now you have new array, and then now maybe we have a convert back new array to a mask function. Again, I don't know that I recommend this, but I just want to, I think this is clearer slightly, but you do get performance hit, right? So yeah, so mask is 0. So then for X in array, actually it's shift and add from the bottom, right? Or from the end, because the last element is the most significant element according to this, right? Wait, so the first element is the least significant bit. No, that's no, yeah. So then the first element is the least significant, so you have to shift and add this way. Okay, yep. Right? And that's it, in theory. Looks okay. I'm gonna give a YOLO submit. Am I confident? Not really, but I'm just lazy. And my allergies is kicking my butt. It may time out. Okay, so it doesn't time out, but there are obviously optimizations that we can make. But that's basically the idea, right? I think it can be really tricky to figure how this is, but you can also do it in different ways, right? You could do the array directly, but it's just that when you use an array directly, then you have to cache yourself, which is fine. Maybe you could use an array and then like concatenate it as a string or something like that, right? And the reason why this is so slow is because we do a lot of conversion back and forth. In theory, you actually don't even need this. You can maybe just, like, if you want to remove this for an optimization, then maybe we'll do it. Then now, just giving the mask. So here, this is the first element. The first element is just going to be mask mod 3, right? That is the last element. And then now this is the biggest element. Is going to be mask shift by, or divided by 3 to the R, right? Something like that. Or minus 1, sorry, right? Because that's the last element. I mean, but that's like really, like, you can work it out at home because this is an upself, but you could try to figure out why this is equivalent to the other one, right? And then now we can say new mask is just equal to mask shift by 3 plus C, and then we mod it by 3 to the R, right? And you can even, like, you know, obviously can put these in a constant or something like that, so that is even easier. Or like it's even fewer commutations. Oh yeah, I forgot to remove that. Whoops. And give it a submit. Hopefully this is still correct. I didn't make a similar mistake. So yeah, so that's already faster. But yeah, there are probably there are other optimizations that you can probably think around, but this is like as basic as it gets, and clearly it is fast enough, and I am happy with it. What's the complexity? Let's go, just to be clear, right? So mask, as we said, it goes from 0 to 3 to the R minus 1, right? So, X is R and Y is goes to C, as we said. So what's the complexity, right? So time complexity is equal to number of inputs times time per input, and number of inputs is just equal to 3 to the R times C, right? And each input takes all of 1 work, all of 3 if you want to say it that way. I mean, it's, you know, like 3 works, all of 1, right? So the time is equal to 3 to the R times C, and that's it. Big O, of course. And yeah, that's all I have with this one. Let me know what you think. Thanks for watching. Yeah, stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.